So the distance of the height of this is 15 feet. Then the ball is thrown up into the air. And then comes back down and hits the ground. Now the first set of questions came from 9.2 and 9.3. The second set of questions are going to come from 9.5. And it says, when will the ball reach a maximum height? We know the word maximum means what? Vertex. And when is time? So this is the t-coordinate of the vertex. Now here's the problem that I had this morning. Because I'm on a second page, I needed to rewrite the formula. And the reason for that was I started using the second formula instead of the first one. So f of x is negative 16t squared plus 102.4t plus 15. That's the formula that I'm working with right now. The other one dealt with how far it was going to be, how high it was going to be, when it was going to be 20 feet off the ground. This one is now for the actual flight of the ball. Well, it's minus b over 2a, which is minus 102.4 over 2 times negative 16, which is minus 102.4 over minus 32. So 102.4 divide 32, 3.2. It's approximately 3.2 seconds. So I know when it reaches the maximum. So remember, the maximum is here. It's the vertex. The x value is 3.2 seconds. And then what is the maximum? Maximum means vertex height. Maximum height. That's the y-coordinate of the vertex, which is f of the x-coordinate of the vertex. So it's minus 16 times 3.2 squared plus 102.4 times 3.2 plus 15. And you notice if you don't have your calculators on this test, you're going to have a problem, or a calculator for this test. Remember, you can borrow one from the math department if you don't have one. You can, the graphers in particular, you can also get from the library.
Is it going to graph?
Pardon me?
Is it going to graph?
No. Some people use graphers. That's fine. That'll work just fine, either one. But for those who are used to using a grapher and you don't have one with you, math department will loan you one. So 3.2, and again I put that in parentheses. That's a habit squared plus 102.4 times 3.2 plus 15. So negative 16 times 3.2 squared plus 102.4 times 3.2 plus 15, 178.84. What? Feet. Now, from the picture point of view, that means this point right here, this height is 178.84. So that's the highest it gets before it starts coming back down. Kind of figure out what happened with the space program. When in the beginning of the space program, they were just shooting out rockets with little capsules on the top. And they would not go all the way and leave the atmosphere. It would go up into the upper atmosphere, and then, of course, then the little astronaut would come down. and then land in water. Well, you kind of figure they had to do a calculation to know how much thrust, initial movement, that it was going to do to get as high as it needed to go, as they wanted it to go, before it would turn around and come back down. So that would be a calculation that they would need. Because they knew what the height was. What they did not necessarily know is what the thrust had to be in order to get it there. Thrust is velocity. That's that coefficient of x. They would know what the coefficient of x is to get it there. So that's a calculation they would have had to do. Because they knew what the height was. And then they come back to Earth, and that's in the beginning they sent monkeys instead of people to see what it was going to do, because they didn't know. I mean, all that stuff was fairly new. Now it's kind of like second nature. You got people living on a space station up there for periods of time. They just now want to know, after a certain period of time of weightlessness, what's going to happen when you return to Earth. Because to get from here to Mars, per se, or that...
Yeah, you can't come back.
You can, well, yeah, that's the problem. You can't come back. Although they do have volunteers that are willing to go. Yep. Right now you can't come back. It doesn't mean in the future you're not going to be able to come back. Might be your lifetime, but not mine.
I think it's the speeds within the problem now. Because you can only go so fast before the human body just starts.
But they don't know that. And they don't know what they're going to have to do in order to make that happen. The Starship Enterprise went at warp speed. And they can still walk around. It's amazing how much, if you take a look at the old science fiction, how much of some of that has come into reality. There's always a little bit of truth. And some stuff, of course, can't happen yet. Okay, last problem of the packet. It says when, that's going to be time, will the ball reach the ground? Now it's giving me a piece of information. What piece of information does it give me? The ground is what? Y equals 0. That's what the ground is. So when you're on the ground, you're at y equals 0. So ground means y equals 0. Or when is negative 16 t squared plus 102.4t plus 15 equal to 0? Because the height off the ground when the ball hits the ground is 0. Or we're a quadratic formula. T is minus b minus 102.4 plus or minus the square root of b 102.4 squared minus 4 times a, which is negative 16, times c, which is positive 15, all over 2 times a, which is negative 16. Or t is minus 102.4 plus or minus the square root of something all over negative 32. And now I pull out my handy dandy little calculator. I'm only going to do what's under the radical. So it's going to be parenthesis 102.4 parenthesis squared minus 4 times a negative 1/6 times c, which is positive 15, which is 114.45.76. 114.45.76. Which is minus 102.4 plus or minus the square root of that. So second square root of 114.45.76, but is 106.9. 107 is good enough. Because if I look at this guy, it's 106.984. So if I round it to the nearest tenth, it's 107. If I round it to the nearest hundredth, yeah, I'm getting close to 107. Might as well make my life nice. Make it 107. All over negative 32. Now, if I take a look at the picture, it only is going to happen once. The other side is going to be negative. So it's only going to happen once. So I know that T is negative 102.4 plus 107 over negative 32. And T is negative 102.4 minus 107 all over negative 32. Or T is minus 102.4 plus 107, and then divide that by negative 32, and it's negative 0.14. And T is same thing, only with a minus in front of the 107. Divide that by negative 32, 6.5. What's my units? So that says that time at ground is 6.5 seconds. .5 seconds after I've thrown it, it hits the ground. So that's kind of recap. I don't know if you have space on your paper someplace. What formulas, and for some odd reason I had space the first hour, but I don't space this hour, are you going to need to know? Well, for this test, we start at 9.2. And at 9.2, we completed the square. And in complete the square, if you remember, it was b over 2 squared, or 1/2 b squared if you had a fraction. That's one formula you're going to need to know, because there's going to be a problem where you're going to have to complete the square. The next formula up after that formula, you had the quadratic formula. That you should always have in your back pocket no matter what if you're going forward. And that says that x is minus b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. This is the formula that's going to cost you a lot of damage if you don't know it, because you already seen a lot of the word problems. It really requires it. The last formula was the formula that we use for the vertex. And the x-coordinate of the vertex is minus b over 2a. This is another one, because of the word problems that are on the test, that you do need to know the quadratic formula and the formula of the vertex. If you forget completing the square, that's only one problem. But these other ones are going to come around more than once. And then the y-coordinate of the vertex is f of the x-coordinate of the vertex.
We can't have a little sheet that has a formula on it.
For the final, you can, but for this test, no. You should be able to remember 4 little formulas. And what you want to do is when you come in, you do a impromptu formula sheet either on the top of your test or on your scratch paper. You just do a formula dump. And then you do have a formula sheet. But it's come from here to your paper, not from your paper to here.